All right, the next problem says, consider the function, we have y equals 2, 1 minus x squared, graph below. What is the coordinate on this plane that maximizes the distance from 1, 0? Now they make it easier because the distance formula has a square root in it, but we can maximize the square of the distance, which looks like this, right? D squared equals x1 minus x2 squared plus y1 minus y2 squared. All right, so the point xy, so it'll be d squared equals, this point here is 1, 0, so let's say it's x minus 1 squared plus y minus 0 squared, right? But y is this, so it'll be d squared equals x minus 1 squared plus 2, 1 minus x squared squared. Well, this is a product, so I can square both of these separately. X minus 1 squared plus 4 times the square root of something. Something squared, you're taking the square root of, turns out to look like this, right? So now, this is what we have here. I'm going to rewrite this one more time. X minus 1 squared plus 4 minus 4x squared. And let's take the derivative of d squared, okay? Equals 2x minus 1, derivative of the inside is just 1. The derivative of 4 is 0. And then this would be minus 8x. Okay? All right, let's finish this up. So we'll set this equal to 0, but I'm going to say 2x minus 2 minus 8x equals 0. Negative 6x minus 2 equals 0. Negative 6x equals 2. I add 2 to both sides. Divide by negative 6. X equals negative 1/3. All right? Well, I can get the y point by taking this negative 1/3, the y coordinate, and plugging it into this, right? 1 minus negative 1/3 squared. I'm going to put that in my calculator. So 1 divided by 3, negative, I'm going to square that. 1 minus that, and I'm going to take the square root of that, times 2, and I end up with something. So y equals 1.8, oops, sorry, 8.85618, blah, blah, blah. So depending on how many points he said, our point would be negative 1/3. I'm just going to see if I can make that a fraction. Nope, 1.89. Right, that'll be the xy point. All right. There's another one in case we needed it. Consider this function, and they give us the derivative of it, don't they? Determine the global max and min on this interval, and also tell them if it doesn't have a global max and min. So what they want us to do, right, is find the critical points. We have the derivative, but we want that to be 0. So let's set this equal to e to the minus x over k, minus 1 over k, k, x minus k, e. Oh, I didn't have to write all that out, did I? I could actually simplify this. That can be pulled out. Right? 1. Okay, so if, oops. Alright, I'm going to simplify this by factoring out an e to the negative x over k. I'm left with 1 minus 1 over kx minus k. So notice, this is 1 minus x over k minus k over k, except when I need this to be a plus, which is